Learning notes about NVIDIA's Build a Deep Research Agent course. Nansen, 2026, January 7. Purpose of this article: to document my learning journey through NVIDIA's Build a Deep Research Agent course, helping interested readers complete the course smoothly, especially by painlessly running the code experiments, and to share my personal reflections on the learning process. Outline. Purpose of this article: what does the Build a Deep Research Agent course ultimately aim to teach? Introduction to the BDRA course. How to successfully complete the BDRA course, running the code experiments, personal learning reflections, additional notes, final remarks. What does the Build a Deep Research Agent course ultimately aim to teach? The Build a Deep Research Agent course, abbreviated BDRA, teaches how to build, deploy, and run an AI assistant capable of conducting deep research. The final output of this AI assistant is a research report. For example, if I want to conduct financial and economic research and generate a report, I only need to give the AI assistant a specific topic, such as Amazon's 2023 financial performance analysis. It will then break the task down into smaller subtasks, search for relevant materials, generate sections of the report, perform reflection and verification, and even allow me, the human user, to provide guidance and constraints throughout the workflow. Ultimately, it produces a deep, high-quality research report. See Figure 01. To achieve this learning goal, the BDRA course covers foundational knowledge and coding methods step by step, enabling learners to gradually acquire the skills needed to build a deep research agent. Introduction to the BDAR course. Build a Deep Research Agent is a free online course in English offered by NVIDIA's Deep Learning Institute (DLI). The registration URL is as follows. See screenshot in Figure 02. Note: a friend of mine had to use a VPN to see the Enroll Now button on the course registration page. Scrolling down the page reveals the course outline. See Figure 03. In fact, the actual learning interface contains a rich set of materials. Interested readers can refer to the later section about the organization of course materials. In short, the course primarily uses 4 runnable Jupyter Lab notebooks to teach learners how to prepare by obtaining API keys, NGC for calling NVIDIA cloud-based LLMs, Pavili for web search, deploy NVIDIA inference microservices NIM containers with advanced reasoning capabilities, deploy a retrieval-augmented generation RAG pipeline for querying private documents, deploy an agent capable of generating deep research reports. How to successfully complete the BDRA course, running the code experiments. This section uses the 4 main notebooks as a guide, explaining key points for smoothly running the code experiments. 01 Prerequisites Notebook. First, if certain web pages do not render properly or buttons are missing, try using a VPN as my friend did. Also, try to watch the introductory video at the start of each notebook. It gives a helpful overview. See Figure 04. Also, NGC stands for NVIDIA GPU Cloud Services. Visit https://catalog.ngc.nvidia.com to begin working with NVIDIA cloud-based LLMs. For the 01 notebook, our main task is to obtain the following two API keys. Table 01 API keys. NVIDIA NGC calling LLMs. Tably web search. 02 deploy NIM notebook. First, what is NIM? It stands for NVIDIA Inference Microservices. These are containerized microservices that make it easier to perform inference calls on LLMs. NVIDIA Nemotron refers to a series of large models derived from open-source models, for example, Llama, but optimized by NVIDIA for efficient reasoning tasks and agentic workflows. Reasoning tokens are a key concept in the 02 notebook. To understand, when calling a Nemotron model, for example, Llama 3_3 Nemotron Super 49 billion v1.5 for inference, you can pass a reasoning parameter. If reasoning is true, the model first generates reasoning text. These are the reasoning tokens before producing the final answer. If reasoning is false, it outputs only the answer. In code, this is controlled by the system content value /nothink or /think. Figure 05 shows an example using the question, how many R's are in the word strawberry, to illustrate the effect of reasoning tokens. Here is /nothink, and the next tokens is 1024. And here is /think, and the next tokens is 65,536. Here is the think part, and then is the final answer part. The 02 notebook experiment is relatively straightforward, but the next two, 03 and 04, require more caution. After finishing 02, take a good break. Next time, restart the entire Jupyter Lab notebook environment, resetting the 4-hour runtime limit, and proceed to the 03 notebook. #03 Deploy RAG notebook. Although this section focuses on the 03 notebook, a heads up, if you restart the Jupyter Lab environment after running 03 and then try to run 04 separately, problems will occur. The 04 notebook depends on the results from 03. A better strategy is to start the 03 carefully, using almost the full 4-hour session, then take a rest. Next time, restart the environment, quickly rerun 03, and then immediately run 04 without closing 03. Now back to the 03 notebook RAG, Retrieval Augmented Generation. Simply put, means searching a private document database for the user's query, retrieving the most relevant document snippets, and feeding both the query and those snippets to an LLM to produce a more relevant and accurate answer. Actually, RAG components and workflows are quite complex. Forgive me for borrowing a complex diagram from the course materials to illustrate this. See figure 06. Here is NVIDIA RAG blueprint. The first part is extraction. The second part is retrieval. In the 03 notebook, however, the focus is on giving learners hands-on experience deploying a RAG pipeline. Getting through the notebook successfully is the goal. Regarding the RAG Playground URL, in section 2.9, access the RAG Playground. Learners are guided to open a web interface to experience RAG. The URL is the host name of the current notebook. See figure 07. This is the host name, and with column A090 appended. Comparison of LLM without RAG and with RAG. Coincidentally, DeepSeek published a new paper on December 21st, 2025 as a New Year's gift. I use it to test whether RAG can enhance an LLM's ability to answer questions about recent information. Collect documents. Then upload the documents to the database, and the system will automatically process the documents. The collection name can only contain letters, underscores, and numbers. Rag off. Don't click to select the collection. The LLM responds with no useful information. Rag on. Firstly, click to select the collection. Then, there will appear collections information. Lastly, send user query. The LLM responds with much detail. And we can see the reg source citation. In the 03 notebook, it's best to run code cells manually one by one. Some code involves pulling and starting Docker images, which takes time, and other code is written as asynchronous functions. If you run later cells before the services are stable or async tasks are complete, problems may arise. Pay special attention to places where the notebook explicitly says to wait before proceeding. '04 Deploy Researcher Notebook. The '04 notebook is the final one in the course. Simply put, the Deep Research Agent's main goal is to generate high-quality, reliable research reports. See figure 01. This agent builds upon the RAG pipeline from the '03 notebook, adding web search for additional context, and introduces more human intervention points and measures in the agent workflow, making the final report better aligned with individual user expectations. Reminder: run '04 immediately after successfully running '03 to ensure the code experiments work. The underlying system mechanism of the Deep Research Agent is shown below, figure 09. During deployment, compared to the 8 containers in the '03 notebook's RAG pipeline, the '04 notebook adds AIRA backend and AIRA front-end containers, totaling 10 containerized microservices. See figure 10. The final working mode of Deep Research Agent app is as follows. Figure 11. User, topic, prompt, assistant, research plan. User can edit the research plan. User, approve the plan and confirm execution. Assistant, generate the report. User, review the report and refine the research, and so on. At last, user, download the final report. An example of the Deep Research Agent app running on a financial economics topic is shown below, figure 12. Agent generated the plan. Agent ran the plan. Agent output the report. Human guided how to edit the report. Agent generated the final report. Personal learning reflections. The ranking method in the RAG pipeline. In Section 5, Understanding Document Retrieval and Ranking of the '03 notebook, the two-phase retrieval process in RAG is explained in detail. See Figure 13. Stage 1 vector similarity search, direct retrieval from query to embedding to search numerous database to top 100 chunks. Stage 2 re-ranking, reference refinement from top 100 chunks to re-rank a model. At last, to top 10 best chunks. I want to highlight that re-ranking here uses a separate model for ranking, not simply sorting by the earlier semantic similarity score. In my experiment, the stage 2 ranking swapped the positions of chunk 2 and chunk 3 compared to stage 1, showing that actual re-ranking occurred. The benefit is that instead of relying solely on semantic similarity, which can be vague, a more linguistically capable model performs a human-like selection, often yielding a ranking closer to human expectation. The drawback is the added model processing step, which increases system latency, computational load, and cost. Characteristics of the deep research agent. Breakdown is key to the depth of the deep research agent. Given a research topic, the agent can break it into multiple subtasks. See figures 05 and 12. Obtain results for each, and finally synthesize them into a whole. This approach is closely related to first principles thinking, divide and conquer, and exhaustive enumeration. Automation without human intervention versus human-in-the-loop collaboration. Essentially, the deep research agent learns toward human-in-the-loop collaboration. This suits scenarios like deep investigation, where meeting the specific needs of the current user is important. If you keep clicking approve and execute, it can approximate fully automated mode. Other agent products such as ByteDance's Anygen app are also moving toward human and AI collaboration. Clearly, for enterprise-grade agent applications, precise human control is a significant requirement. The deep research agent still cannot fully meet individual human expectations. In my 04 notebook experiment on financial economics research, Figure 12, after the agent generated the first draft, I entered the prompt "list outlines" in the front part of the report to ask the agent to add an outline. The new version did include a report outline section. However, when I checked whether the outline items matched the subsequent section headings, I found it difficult to see a clear correspondence, almost as if hallucination had occurred. This likely requires further dialogue with the agent describing my needs in more detail to better achieve the desired outcome. Additionally, I believe the underlying models in this deep research agent system need more post-training and testing improvements to more intelligently grasp common research requirements. Additional notes about the organization of course materials. The high-level framework of the Build a Deep Research Agent course is shown below Figure 14. Build a deep research agent, and then course materials. It includes interactive environment and assessment question, and then workshop survey. It includes feedback. The primary learning activity takes place in the interactive environment, which opens automatically from the course homepage. Learners see an introductory text, Figure 15, an overview video, and then are asked to launch the Jupyter Lab notebook environment. After about 15 minutes, the Jupyter Lab interface appears, Figure 15. In the left-hand file tree view, you will see 5 notebooks from 00 to 04. Each notebook starts with an overview video followed by the learning and experimental content. After completing the notebooks and successfully running the code, learners can proceed to the assessment questions section, Figure 15. For theory exercises, then to feedback to submit course feedback, Figure 15. After all these steps, the course name appears in the completed courses section on the My Learning page, Figure 15. At that point, you're done. Congratulations! Final remark. Well, finally, the last section, I started learning the Build a Deep Research Agent course on January 1st, the New Year's Day, documenting the process and writing these notes, and have been busy until January 6th. The 3-day New Year holiday felt like no holiday at all. I even had to add 3 more days just to write this article. Actually, overall, this course is quite beginner-friendly. However, it still requires some foundational knowledge. I think it's best suited for someone at my level. So what's my level? I'm the person who won the Excellence Award. No, here is a pair of double quotes. In the NVIDIA Agent Hackathon China 2025. Back then, I had zero exposure to NVIDIA agents. That hackathon gave me hands-on experience with agent deployment and sparked my learning about agents. Starting Build a Deep Research Agent now feels like a follow-up special topic, focusing on how to use agents to produce high-quality research reports. This mini hackathon style of learning has deepened my understanding of agents once again. Hope we can all progress together in the NVIDIA community in 2026.